Hello, in this video I'm going to be going over electron configuration of ions. Remember, ions have different numbers of protons as they do electrons. Right, start with a simpler one like calcium, because it's not a D block element. Alright, calcium is 1s2, 2s2, 2p6, 3s2, 3p6. So we're going 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And it's 2 plus, which means we remove 2 electrons. We have 2 less electrons than we normally have. So you're going to pull those electrons out from the outermost energy level. In this case, it's the 4. So that you're going to pull out. And you can either omit it and make it look like the electron configuration that of argon. What I usually do is write 1s2, 2s2, 2p6, 3s2, 3p6, 4s0 to signify that it's actually calcium. Should have 4s filled, but they're gone, which makes it a cation, 2 plus charge. Alright, let's do something a little trickier. Let's do zinc. Zinc is in the D block. 1s2, 2s2, 2p6. So going over here, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So 3s2, 3p6, 4s2, 3d, because D's are one less than row they're in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it's a 2 plus charge. So the last 2 electrons we put on were on this D orbital, but we have to pull the electrons from the furthest energy level. That's this 4th energy level. So instead of 4s2, it's 4s0. We're pulling them from there. You can either write 4s0 or just omit that from your electron configuration. Alright, doing one more example, let's do cobalt 3 plus. First of all, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, so it looks just like the previous 2. And then we have 3d, 1, 2, 3, 4, 5, 6, 7. So we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 7, but it's 3 plus, which means we're losing 3 electrons, and we're not pulling them from the 3d first, we're pulling them from the outermost, the 4s. So this is going to go away, and one of these will go away. So if we rewrote it, it'd be 1s2, 2s2, 2p6, 3s2, 3p6, 4s0, 3d6, or you can omit the 4s0. And it looks like we haven't done an anion yet, so why don't we do selenium? Selenium is right over here, SE number 34. We got 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p1, 2, 3, 4. Alright, that's a longer one. 2p6, 3s2, 3p6, 4s2, 3d10, 4p4, but it's 2 negative, which means we have 2 more electrons than normal. So instead of 4p4, it's going to be 4p56, 2 extra. So we'll scribble that out and put 4p6, and that's the electron configuration for Se2-.